Good morning, geometry. Okay, today we're going to be moving forward and taking all the things that we have learned about prisms, specifically rectangular prisms, and we're going to be moving to our cylinders. So let's take a look at our cylinders. I'm going to go get my figure. All right, so here's a cylinder. It is just like a prism because the bases are parallel and they're the same. So in this case, my base is a circle, right? So we're going to be looking at how to find lateral area, surface area, and volume of a cylinder. So I'm going to open it up for us. And we have, this is what a cylinder looks like when you open it up to see the net. So if you notice the net here, it's a rectangle, right? The lateral piece of the cylinder is a rectangle with two circular bases. So very interesting to think about when you open up a cylinder, what the lateral face is. Not really a face, but the lateral piece here is a rectangle. So that'll kind of give us an idea of how to find that lateral area. So here's what we'll talk about with cylinders. We're talking about lateral area, right? And surface area and volume. So lateral area, surface area, and volume are all the same for prisms. They're all the same. So in this case, it's your lateral area is the perimeter of your base times your height, right? And the surface area is the perimeter of your base times your height plus twice your base areas. We've seen those before. And then your volume is your big base area times your height. What will change is how to find the perimeter, because we're finding the perimeter of a cylinder base here, which in this case is a circle, right? So here's our cylinder. When we open up the cylinder and find the net, it looks like this, or it looks kind of like this, right? So if you think about a cylinder, this is our net, right? So this is our lateral area, this piece right here. So I'm going to just highlight this just so you can see. The lateral area looks like a rectangle, right? So perimeter of your base here, that's P, and the height, in our orange, is this orange piece, right? So now I gotta go find my green one. That way you can see the base area. So if we colored all this in, if we found the area of the base, that would be our base area. So just a reminder of all of those things. P is perimeter of base. And in this case, if I wanted to find the perimeter of a circle or the distance around a circle, that's called your circumference, right? So the perimeter of a circle is really called your circumference, which in this case, the formula for circumference is pi times diameter, or 2 pi r, either way. Perimeter of a base. Height is the same thing, height of the figure. We find that the same way that we would find it in a rectangular prism. It's the height of the figure. And then the big B, the base area. In this case, because our base area is a circle, we want to know what the area of a circle is, right? So area of a circle is pi r squared. And so if you notice in our calculator here, we're going to be using this pi button a lot. I don't want you to use 3.14 on your quiz. I'm going to use the pi button for your answers. So make sure you use that pi button. But here's our information for our cylinders today. And we're going to be doing some examples with these. And we're going to be talking about composite figures in class today. So let's look at a couple of examples. If you're following along with me, then I am on example number, or exercise number 4 in your first notes. So we have this cylinder. My radius here is a 6, and my height is a 5. You don't have to have too much information, right? I want to find the lateral area and the surface area. So lateral area, let's remind ourselves, is perimeter of the base times the height, and perimeter of a circle is circumference. So I'm going to rewrite this as pi times diameter times height. So in this case, they gave us the radius, right? Radius equals 6. So therefore, all the way across my circle, diameter is 12. Remember that term, diameter? So we're just going to plug in that value, 12. The height of the figure is 5, and we're going to attach on our pi at the end. So let's see what this looks like. We have 12 times 5 times pi. There we go. 188.495 or 496, and it's in meters, so I want to put meters squared. Okay, now let's look at surface area. That was my answer. I'm going to box it, make it all pretty. Right, surface area is your lateral area plus twice your bases, or perimeter times your height plus twice your base area. So let's see. I already found that, 188.496, and I'm going to add my two base areas. Well, base area for this is the area of a circle, pi r squared. 2 times pi r squared. My radius, looking back at my question, is 6. 6 squared pi 2 plus 188.496 gets me my surface area. That was supposed to be an S. So I'm going to multiply my 2 and my 6 squared. You got to do that first, right? 6 squared is 36 times 2 times pi. So that's 226.195. And we're going to add that number to 188.496 to see what our total surface area. 226.195 plus 188.496, and our total surface area is 414.691. That's our total surface area. Seems like a pretty large number, right? Meters. Oh, meters. So meters squared. All right, let's see what it would be if I wanted to find the volume of this cylinder. Let's look at volume. We found lateral area, surface area, and now we're going to find volume. I'm going to remind myself what my formula is. It's your big base area times your height. In this case, my base area is pi r squared, right? Pi r squared times the height of the figure. Your radius is 6, so we have pi times 6 squared times 5. So I have 36 times 5. Don't forget to square your number first, times pi. So our volume is 565.487 meters cubed. Notice the difference. When we're finding area, it's squared. When we're finding volume, it's cubed. Let's try another one. We have a skinny long one here. This is number 5. And in this case, we're given the diameter instead of the radius. So we'll have to do a little bit of figuring. So we have all the way across our circle at the top is 24. So that tells me that the diameter is 24. And then my height here is 52.8. And they're both in feet. All right, so I want to find surface area of my cylinder. Oh, no, sorry. I want to find the lateral area of my cylinder first, which is perimeter of your base times your height. Going back to my notes, perimeter is the circumference, right? So my circumference is pi times diameter and then times your height. So I already have my diameter. That's great news. I'm going to say pi times 24 times 52.8, and that's going to give me my lateral area. 24 times 52.8 times pi gives us, that's a huge number, lateral area, 3,981.026 feet squared. So that's our lateral area. That's just the distance around, like painting the walls, right? So remember here, your perimeter, because it's a circle, we're using circumference, right? Going all the way around. In the rectangles, we just added up all the sides. That was pretty easy. This one, we actually have to use the circumference formula. All right, so let's find surface area. Surface area is perimeter of your base times your height plus twice your base areas. I'm going to use the number that we already found, 3981.026, plus twice your base area. In this case, because my base area is a circle, I'm going to use pi r squared. Oh, but here we go. I have my diameter. How do I find my radius? If my diameter is all the way across, my radius is halfway across, so it's 12. So here we go, 3,981.026 plus 2 times pi times 12 squared. Square your number first, so it's 144 times 2 times pi, 904.779 plus 3,981.026. Let's see what our total surface area is. This is going to be a big number. 04.779 plus 4,885.805, and that was feet squared. So that was your total surface area. So let's think about this reasonably. Does it make sense reasonably that your lateral area is 3,900 and your surface area is 4,800? Well, yeah, look at how long this is, this 52.8. If this is 52.8, that's a pretty big number. So there's a lot of area to cover when you're going around the circle or the cylinder. The bases are a little bit smaller, so we're going to add a little bit less to our lateral area there. All right, last one, let's find volume. Volume is big base area times your height. So we're going to do the same thing, big base area, big base area. We had to find pi r squared, right? So we're going to do that again, pi r squared times your height. Let's plug in our values, pi times 12 squared times 52.8. So remember to square first. We're going to do 144 times 52.8 times pi. 23,886, 15726. I don't know why I put all those numbers, feet cubed. We can round it to the nearest tenth or something. So here's the thing. If I had square feet, right? That's how many square feet or cubed feet I could put in the thing. So think about that. If I was filling the cylinder with cubes like this, but rounded, I guess, because it would be full, I could fill it with 23,000 of them. That's pretty crazy. That's a huge number. All right, so that is our lateral area, surface area, and volume of cylinders. We're following the same formulas as we did for the rectangular and triangular prisms, just have to replace those perimeter and area with your circumference formula and your area of the circle formula. So let's move to our next one, our next notes. We've already found some of them, so I want to move down to, no, I think we can do these in, oh yeah, this one, number 6 on your second notes. Number 6 on your second notes. We have this sideways cylinder, looks like this. And it's kind of like one that we had in our last notes. They gave us the volume, here's P, and they gave us the height of the figure. but we have to find out what that missing radius is. So here we go. Let's think about what our volume is. Our volume is big base area times your height, right? So we're just finding this missing radius. Base area, looking back at my notes here, is pi r squared. So pi r squared times your height equals volume. Now let's plug in what we know. We know 75.36. We know pi. We don't know radius, but we know our height is 6. So I'm going to rewrite this a little bit so it looks a little bit better. We have 6 pi r squared equals 75.36. Now I'm going to get rid of, because now I'm solving an equation, right? I want to get rid of that 6 and the pi. So I have 75.36 divided by 6 pi. Let's see. .99. So I'm going to say that is, well, let's leave it as 3.998, right? 3.998 equals radius squared. So here we go. What do I do now to solve for I? What is the opposite of squaring? And we get stuck on this a lot. It's taking the square root. Okay, the opposite of squaring is taking the square root. So in order to solve for r, we're going to take the square root of both of these numbers. So let's see what this is. The square root of 3.99, what did I say? 70998 is really close to 2. So let's just go ahead and round that baby up to 2. So our radius here, P, is 2. So same thing like we did with the prisms. We figure out what our formula is, and then we narrow it down and we solve it just like we would a regular equation. This is the only tricky part, is the opposite of squaring is taking the square root. We'll do some composite figures together in class, and I'll see you soon.